We got a new video on substitution. This is lesson 2.2. I ran you guys through the procedure of how the substitution method works. We did a few examples. I'd go back to that if you're still really confused. In this lesson, I'm going to show you guys what some of the special cases look like. So when you were graphing, we had parallel lines, which indicated no solution, and we had two lines that were basically overlapping on every single point, infinitely many, or all points on that line. The same thing's going to emerge when you solve linear systems. So I got 4 examples. Let's just explore those using 2.1 methods. So if you recall, we had 4 steps. Step 1 was get x or y by itself. You pick an equation and you solve for x or y. I'm going to go with this top one because the y value in the top one doesn't have a coefficient out front, which means it's going to be the easiest one to get by itself. So step 1, all you got to do is subtract 2x from both sides. 0 plus y equals 3 minus 2x, or negative 2x plus 3. Yeah, so now, this is an equation of interest, all right? We really want to highlight that and keep it in mind, because it's going to be a key part of the next step. Step number 2. Take that equation. So take the step 1 equation. Let's make sure you guys can see all this. Looks like it. Take the step 1 equation. The step 1 equation. Plug it into the other one. I'll just call it the other equation. So the other equation is 4x plus 4y equals 8. If I got y by itself in this one, I'm basically saying the y here is going to be replaced, all right? I'm going to use some fancy work here. Replaced with the yellow expression. All right? This equals 8. See? 4x plus 4y equals 8. 4x plus 4 blank equals 8. So the blank is the negative 2x plus 3. So I'm plugging the negative 2x plus 3 right in there. Maybe I can use a different color. Do I got a green marker around here? I sure do. Negative 2x plus 3. And then you solve the equation for x now. This is something you guys saw in Math 1A extensively. You saw it a bunch. So 4 times negative 2x is minus 8x. 4 times 3 is positive 12. The 4x just drops down. The 8 drops down. You combine like terms where you see them on one side, so that's negative 4x. And you're left with a fairly simple equation to solve. Get x by itself. You need to get rid of the plus 12 because it can combine with the green 8. So that's negative 4x plus 0 equals 8 minus 12, negative 4. Pay attention to your negatives and positives. They're going to make a huge difference here. Divide by negative 4 on both sides. That creates a clean x. 1x equals anything divided by itself is 1. So now the end of step 2 gives us x equals 1. So then step 3. Plug in the step 2 result the x equals 1. Okay? Plug in x equals 1 into the step 1 equation, because it's the one where it's already gotten y by itself. We solve for x equals 1. Now we need to solve for y, which is right here. Y is already by itself in that equation. Plug the result into step 1. All right. So y equals negative 2x plus 3 is our step 1 equation. I'm plugging in y equals negative 2. Instead of the x, I'm going to put x equals negative 1 in there. Negative 2 times negative 1 plus 3. So negative 2 times negative 1 is positive 2, and you get y equals 5. All right, step 4 is write it as an ordered pair. So that's the x comma y. Your x was negative 1. Oh, shoot, it was 1, not negative 1. Let me go back and change that really quick. X was 1. That's 1. That's negative 2. And that would create a 1 here. My apologies. So now it's 1, 1. X was 1. Y was 1. All right, so there's nothing new so far. Nothing new so far. You just use the 4 steps to get x by itself and y by itself, and then that's the answer. I think number 2, you're going to see how things are changing, though. So on number 2, same step-by-step method. Step 1, get x or y by itself. I think I'm going to choose the top equation again. And I'm going to, you know what? I'm going to add y to get rid of it and put it over here. That'll give me positive y minus 1 equals 2x. And then I'll just add 1 to both sides. So y equals 2x plus 1. In fact, this is the important result. I'm going to put it in a different color. And put it in parentheses, just to remind myself, that's the expression, that's the quantity that goes in parentheses. So step 2 is where I take the second equation, 4y minus 8x equals 4, and I'm plugging in for this y right here. I got y by itself, so y is actually going to be replaced with some quantity that I got by itself. So it's going to be 4 times 2x plus 1 minus 8x equals 4. Now using the distributive property, 4 times 2x is 8x. 4 times 1 is positive 4. Minus 8x equals 4. Now at this point, this is where things get tricky. I've got an 8x here minus 8x on the same side of the equation. What's 8x minus 8x? 0x. What's 0 times anything? 0. It's gone. You're gone. You're gone. 4 equals 4 is what's left over. And that's a true statement. But the x's are gone. So what are we supposed to do? If the x's drop out, if the x terms cancel out, and you're left with like a true statement right here. 4 equals 4. A true number statement. In this case, 4 does equal 4. Then that means that both of these equations were the same from the get-go. So think about it like this. 4y minus 8x equals 4. If I get y by itself and it's the same as 2x plus 1, then we would have APOL. Infinitely many solutions. So I can add 8x to both sides. 0, 8x plus 4. Divide by 4, divide by 4, divide by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Yeah, they're identical. It's all points on the line 2x plus 1. Or infinitely many solutions. I'm sorry, you guys couldn't see that. But I'm not going to restart the video because we're already 12 minutes in. So, if the x terms cancel out and you're left with a true number statement, okay? It's all the points on the line or infinitely many solutions. In this case, y equals 2x plus 1. All right, so there's the first special case. I'm going to stop this video now so you guys can just at least digest APOL, and then on the new video, I'll talk about what the other special case looks like.